After giving an overview of DC-DC converters in the previous videos, in this video we introduce different classes of DC-DC power converters. The main learning objectives will fall under the two main questions. Firstly, what are the different classes based on the direction of the power flow? Secondly, what are the classes of the previously introduced DC-DC power converter topologies? As we discussed in the previous video, DC-DC power converters change the input voltage V in to a different level of output voltage V out. The electrical switch is one of the most important components of any DC-DC converter that receives the control signals from the controller. These control signals contain information about the switching frequency and duty cycle. Then we introduce diodes which enter the on state typically when the switch turns off. These antiparallel diodes or freewheeling diodes allow the current flow of the inductor in the circuit of the converter. Finally, as already discussed, capacitors are used to reduce the voltage ripple at the output of DC-DC converter. Many DC-DC converters, like buck, only allow the unidirectional flow of the power from input to the output. However, there are topologies like buck and boost or dual active bridge which have bidirectional capabilities allowing the power flow from the output to the input. Here we introduce 5 classes of DC-DC power converters. Class A only allows positive output voltage and positive current values. As a result, the power can only unidirectionally flow from input to output. Class B only allows a positive output voltage and a negative output current. As a result, the power can be transferred only from the output to the input. Classes A and B are 2 examples of the so-called one-quadrant converters. However, there are also examples of 2-quadrant converters. Class C allows a bidirectional flow of output current, however only for a positive output voltage. Class D allows also a bidirectional power flow, however only for a positive output current. The last and the most complete one is Class E, which has a 4-quadrant bidirectional capability. Class E is the most complete class which offers all the solutions, 4-quadrant operation. However, Class E has a higher cost than Class C, which can offer all the necessary features required by the DC microgrid. This is mainly due to the fact that DC microgrids are operated typically in a fixed voltage polarity. Therefore, Class A, B, and C are the most suitable operating options for DC microgrids. In the next slides, we identify and discuss these classes for the previously introduced DC-DC converter topologies. We determine the class for the configuration of a conventional buck converter. Note that since the input voltage of a buck converter is greater than the output voltage, then the current of the inductor will not obtain negative values. Therefore, buck converters are considered as a Class A. What about the conventional boost converter? We learned that they step up the voltage at the output. Due to the placement of the diode at the output of the boost converter, it does not allow the current to flow from the output to the input. Therefore, similar to buck converter, boost converters are also falling under Class A. Buck and boost converters are expected to provide a higher degree of freedom and flexibility, mainly due to the use of the additional switch S2. They are also a combination of these 2 converters, buck and boost. They are able to allow the bidirectional flow of the current, and as a result, buck and boost converters fall under Class C. The flow of current from the output to the input becomes possible using switch S2. We analyze a full bridge DC-DC converter. The full bridge DC-DC converters consist of the 2 legs and 4 switches. Thanks to 4 switches, the full bridge DC-DC converter is able to support both positive and negative voltage outputs that can be used as 4-quadrant. The bidirectional current flow becomes possible due to the diodes in antiparallel with switches. Let us now see the topology of a more complex converter like DC-AC, DC topologies. They first convert the DC to AC and then AC to DC. One example is shown here where a diode bridge is used to convert AC to DC. Beforehand, the input DC voltage is first inverted to AC using a two-leg 4-switch single-phase converter, and then the AC voltage is stepped up or down through the AC transformer. Note that due to the placement of the diode bridge rectifier, the negative output currents cannot flow. As a result, this topology cannot be operated as a Class C and only as a Class A converter. What about the class of a dual-active bridge converter? These converters are one of the most flexible converters with respect to the flow of the currents. However, as most of the DC microgrids are operated with the fixed voltage polarity, either positive or negative, then the dual-active bridge converters are operated at a Class C. In this video, we first reviewed the main elements of DC-DC converters. Then, we introduced 5 different classes of DC-DC converters, mainly based on the polarity of output voltage and the direction of the output currents. Boost or buck converters can allow the unidirectional flow of power, while buck and boost, full bridge and dual-active bridge are able to facilitate bidirectional power flows.